This is question number 24 of capacitors. This is a kind of a wheatstone bridge they've given. Just the difference is these are not resistors, these are capacitors. So the analysis is a bit different. And then they have given two more figures that are basically the same. You can basically change the point of view, change the points, write all the resistors, and you'll get the same thing as this. Add more wires, same thing. But uh, what's is the matter of concern is you have to calculate the capacitance, the equivalent capacitance for the whole thing. So it's kind of a Wheatstone bridge. We know when we do analysis of a Wheatstone bridge, we remove this man, and also the ratios are same. But of course, in H.C. Verma, they have not explained uh, the ratios of the Wheatstone bridge and all, at least till capacitors. So how will we are we going to do analysis? Of course, we have delete. I've deleted the 5 microfarad one for a second. It's the convention. So let me do an analysis of this portion and this portion. Right. Now, I am assuming. See, charges don't divide, current divides. During when we talk about resistors, we talk about currents. Since I'm assuming a charge coming, I'll not assume. I could have assumed. I can assume a bob of mass, but it's simply not the convention, of dividing Qs. So I'll assume a 3Q charge for some value of Q. A 3Q charge moves from this A. It will get divided. The above one will get some Q dash and the below one will get some Q double dash. Enough. So and the equivalent capacitance of the thing above will be how much? It's 3 times 1 is 3 and 3 by 4 is 3 by 4. So let me name some points. इसका नामकरण करते हैं. A and N. We have the current. And N and M is now. So the capacitance of Kn, sorry, अच्छा N दो बार आ गया नामकरण. You can have R. Kr is 3 by 4 and of course we are not talking about ratios. You can prove it by ratios. In Wheatstone bridge we use ratios, but it's even hasn't taught us ratios. Yes, we're not going to solve it by ratios, but you can derive it from ratios, and I have used the word ratios, I believe, more than 7 times. But anyways, 2 6 are 8 and 8, sorry, 2 6 are 12 and 12 by 8. How much that is? It's 3 by 2. Who cares about microfarad? So yeah, just assume these are farads. So we'll just write a micro in the answer. Yeah, so yeah, so you have the capacitance, the equivalent capacitance. These are not wires, these are just for, you know, diagram sake. The sake of diagram. See, we know the formula for voltage. See, voltage remains same. Now, why it remains same? It's basically the approximation of integration using the Riemann sum. But anyways, it remains same. Just assume the voltage remains same in parallel. So the voltage is given by Q by C. Of course, we're talking about the red one above. It's not a wire. I'm basically referring to this whole part. So the voltage should be equal to Q by C KR, which should be equal to the Q double dash upon C NM. Uh, Let me compare Q dash upon C KR. C KR. C KR is 3 by 4 and Q dash NM is 3 by 2. 3 3 cut. Q dash is equal to half of q double dash. And if they, of course, sum to 3, you have 3q dash by 2 is 3q, and you have the 2 and 1. Okay, that's why I chose 2 dash. But it's still clear from this only. You do not need just 3q. That q dash will be half of this double q in, of course, in values. But I do not want it in fractions, so of course assume q and 2q only. This was a right, like way to tell. Q dash is half of double q dash, and if they add, so q dash, if they add to 3, then 3q by 2, q dash is equal to 2. So यहाँ पर 2q जा रहा है, and यहाँ पर अकेला 1q जा रहा है, right? And we know 2q is equal to q is half of 2q. So let me erase this q double dash thing. We'll assume a q and 2q charge moves through here. Now you know in a series of capacitors, the charge remains same. And we're talking about this series, so the charge will remain same. Bro, there's q here, there'll also be q here. And if this q here, there'll be 2q here, and there'll be 2q here. Now let's talk about this capacitor. In this capacitor, you know that q is a charge which is equal to the 1 microfarad times some potential difference, which is the potential here, which I consider to be V. I consider it to be V, and of course the B potential of B zero, and this higher potential and its lower potential. ठीक है. V minus, let me assume some kind of a potential V curve or V cursive. V cursive. Of course, it's not the same. That's what we are going to prove. It's lambda. Yeah, it's the potential. So V minus V cursive is Q, and it's 2Q here. So for let's talk when we talk about this small, so 2Q is equal to 2 times V minus lambda. And of course, we can do and half and equate the Q's. We get V minus is V minus lambda, V, and we get cut. So lambda is equal to V cursive. It's appearing as V cursive, it's V. So lambda is equal to V. So the potential between these 2 points is going to be same. Potential between these 2 points is going to be same. If the 5 microfarad was not there, let's assume we put a 5 microfarad here. Since the potential is zero, the charge is going to get a zero. And since the charge is going to get a zero, it's not going to change the potential. And it's like a circular argument. Since the potential is zero, it's not going to get charges. And since the charges are zero, the potential will be zero. So it will not change the potential. So it's basically an unnecessary addition. You can prove it by another way also. I tried proving it. That's using ChatGPT. You can make what charge distributions. That is like a Q1 here, Q2 here, Q3 here, Q4 here. I did make them. Then what I did was I got the potential between A and B as first I went through here, the above path. Then I went through here. Oh, sorry. Then I went from here to here. Then I took this path. Then I took this path, and you have to make the potential difference for all and then make the equation. I did make the equations, and I could not solve about seven linear equations. There were about seven. These were the linear equations. First, I gave this q1 plus q2 is q3. I assume this is q3 minus q3 and minus q4. Of course, q3 and q4 are assumed to be positive. That's why I was putting a minus sign. And then the potential equations, I basically equated them. I forgot to give it the equation that was C1 by C3 is equal to C1 by C2 is equal to C3 by C4. So could not solve. But then I gave it the C1 by C2 C3 by C4. Then it did solve for these equations. And so finally it did prove that Q2 is equal to Q4 and that Q5 is equal to 0. Because Q5 was referring to this one. Q5 was 0, Q2 was Q4 was equal to Q4, the minus charge that was coming from here. Of course, you can say it's minus Q2 and it's minus Q2, so plus Q2. So there's no net charge. The Q5 was 0. And then you can calculate the potential as Q by V. Here it will be Q2 by Q2 by C, right? Q2 by 2. And since see, the thing is, it's somehow did can prove, like I can prove that since the charges here are same, uh, it can we can prove Q1 is equal to Q3 by these only. See Q1 and Q3, C3 by C4, Q2, Q2. So Q1 is equal to Q3. Q2 is equal to Q4 and Q1 is equal to Q3. Okay? So it's going to add to 0, it's going to add to 0. And when you put it in the equation, and Q5 is 0. And of course, if we have proof Q5 is 0, that means there is no potential. Why I'm talking about Q2 and Q3 here to help with Q2 and Q3. Q5, by these equations have proved Q5 is A0. That means there's no charge. That means Q is equal to CV or what? V was Q by C and it has some capacitance 5, but the charge is 0. The potential difference that it's going to offer is 0. So you can just go by these two above wires and just ignoring the 5 microfarad. So that was how we solved this question, and see you later.